Ready. Okay.
Yeah.
Sorry, so sorry. Okay. Now the technology is like this. You need to be more fluent than the normal people. So give me a moment just to check everything is fine. Alive. Perfect. Yes, we are online. Okay, Rosa, when you want. I will admit, give me a moment. We have 3 persons in the waiting room. Great.
Good morning. Hola, Beatriz.
Everybody. ¿Qué tal? Hola, Ángela, ¿qué tal? How are you?
Fine.
Nice to see you.
Nice to see you too. Good morning, everyone.
Buenos días, buenos días, buenos días.
¿Qué tal, José Ángel? ¿Cómo andas? No te veo, no sé dónde estás, pero te escucho.
Aquí está, ahora sí te veo, ahora sí te oigo, ahora sí te abrazo, ¿verdad? A pesar de que la geografía se interponga.
Sí.
Pero la dominaremos y haremos que nos obedezca.
Please indicate in the chat your country. Edit your name and indicate your country, just to have the full list of involved people in this meeting. Okay, Rosa, when you want. We are a bit late. Part is my fault, sorry. Rosa was out. I don't know why. Rosa.
Rosa tan maravillosa.
I think Rosa mute herself, Rosa.
Rosa?
Please unmute.
Rosa, el micrófono.
Abre tu micrófono.
El micrófono.
Rosa, you are mute. Estás muteada, estás silenciada, Rosa. A ver. ¿Podés arreglarlo? A ver, Rosa.
Ya está.
Okay.
Sorry. I need to share now the PowerPoint.
Wait a minute, Rosa.
Okay. Sorry.
Ready. Go out.
Okay. Well, I hope that you can see the PowerPoint.
Yes, we can. Not in the presentation mode. Yeah, perfect, Rosa.
I'm very happy. Okay. Well, at first I want to say thank you very much to participate in this meeting. Welcome to the third Bridges Between Cultures. When we began 2 years ago, we planned to continue every year, and we are very happy that we can do it with many participants, and every year the project of NASE and UNESCO grow up. In this first introduction, I would like to mention the aspects of astrobiology in NASE program. As you know, we have 5 different kind of courses, and the course of astrobiology begins in 2018. And at the beginning, we have 4 workshops. One workshop was the big case of the young astronomers. And this was not very astrobiology topic, but we put because we thought was interesting that the people knows that there are exoplanets in all the parts of the planisphere. But finally, this year, we decided to create a new workshop that we prepare slowly for many years ago. But in this case, we begin to work strongly with the group of astrobiology of Muriel Magot de France. And we believe that it is important, this connection with professionals in this area. Then we decided to create a new workshop, the workshop 11, that you know is a new, because we have only 10 workshops just now. And it's not really in the website, but it will be in the website in short, okay? Well, I would like to mention that we modify the workshop, especially the more beautiful aspect of the workshop, the website. And in this new website, you can find all the information that you have before. The structure is similar, they might think you can work without problems. And you can discover that here in the right, when you put English, you can find your language. In this moment, we have more than 25 different languages. And I want to say here, thank you to everybody, because as you know, we need your help in order to translate them. I think this is very important because we insist that it is necessary to teach in the language of the country and or the area where we are working with the teachers. It doesn't matter if it is official language or not in this place. Well, you can see in the course materials that you have, of course, all the PowerPoints, and we will introduce the new one workshop in a short time. But I would like to insist that you revise the previous workshops that you know, because every January we introduce the changes in our materials. In some cases, we introduce maybe one model more, one detail more, one concept more, or in some cases only try to clarify one slide that we believe that because some comments that we receive are not so good or so accurate, and when we modify, okay? And also we are introducing more and more videos. Today I received from Ricardo. Ricardo is the how do you say, the leader of the videos, because he correct, modify and create more videos. And this morning sent to me 20 new ones. I didn't have time to put there, but I recommended that you try to observe during the next week the new videos that we have, and also the workshops that we modified. We will put also next week new versions of workshop 7, 10, and 11. And in this moment, you have a new version of the workshop too. Then I would like to recommend them especially that always before to teach a new one course in NASE, revise the website and revise the materials that you have from previous editions of NASE courses. Well, in the workshop 11, we introduce more activities on astrobiology. Really, we mix in some way workshop 10 that was before workshop 10 with the workshop 11. Then I recommended that you revise both of them. And in particular, we introduce a calendar, a cosmic calendar, that it was introduced many years ago, that it is very interesting to compare the year with the universe and to recognize what is the part where appears the life. It is very, very small. But we introduce also with a line, and in this case, it is possible to put more activities connected with all of this. Then I think it is a good idea that you try to discover all this new information, because of course we will continue with courses of astrobiology that in this moment is one of the topics news that we have, of course. And there are many countries interested in this new area of NASE. Then thank you very much for your help, for your cooperation. Of course, it is a good idea, especially for the leaders in each one country that they promote the courses. And when they organize the courses, if you have any comments about the topics that we introduce, the new topics or all ones, please contact with me, for instance, or with Beatriz, because we use all this information. NASE is not sleeping, continuously change, and we can do it because all of you help us. And this connection is absolutely essential. Then all this information will be in the newsletter also, but please contact with people in your countries and promote especially the project of UNESCO of this year, because it's a project related to astrobiology. I don't talk about this because it will be Ricardo Moreno, the person that who explained this project, and also Margarita Metaxa will insist again, okay? Then it is only, I want to say that it is a project in order that our students looking for micrometeorites. It is very exciting for students when they have in their hands one small piece of extraterrestrial material. This arrived from other planets or comets or other parts of the solar system, and is a simple, easy, and cheap way to get this kind of materials, okay? Then I would like to finish with this and to give the opportunity to Beatriz that begin to work, and we try to continue with a good time in this 3-hour session. I finish to share my PowerPoint, Beatriz.
Okay, yes, well, perfect. Thank you, Rosa. I will share, if I can, my screen. Well, as you know, I am not a specialist in this topic, but Rosa asked me for this, so I will try to do my best about an introduction to the exo and astrobiology, what means, and please tell me if you can see my screen.
Yeah.
Okay. Well, one of the most common definitions of life arrive us from a discussion on astrobiology in a meeting organized by NASA. As you can see, life is a self-sustaining chemical system capable of undergoing Darwinian evolution. It's good, this definition, because in the definition, the life is not just the life we know on the Earth, but also can be life in other worlds. And moreover, we have the evolution thing in the definition. To speak about life, we need to speak about worlds to have life, a special habitats for the development of life. And we need planets and exoplanets. And in the formation, we know that the star and all the material in the original cloud or interstellar cloud of different elements are formed. You have the clues, you have the keys for the appearance of life. The formation of the star and the planetary system arrive from the same material, and we have the tools to study the chemical composition through the amazing techniques we call spectroscopy. We know the composition of the stars, we know eventual composition of the planets and their atmospheres. To detect exoplanets, you know, we have several methods. One of these is the transit. We know very well this method. The light curve permits us to know that a planet is in front of a star. And we all know very nice detections in the past years thanks to the Webb telescope. Here is the transit light curve of WASP 96b. And this curve permits us to calculate even the dimensions of the planet, but more than this, because if you observe the light of this kind of detection in different wavelengths, you can also determine different chemical elements in the atmosphere of the planet, because the atmosphere blocks more or less some colors, and this is connected with the chemical elements in that. The other way to detection of exoplanets is using the radial velocity techniques. And we know we have a star, we have the planets, and both are moving around the center of mass of the system. The star sometimes is moving to the observer and sometimes opposite the observer, and we can see the difference in the light, and from this we can determine the radial velocity curve. In the last decades, the astronomers detected a lot, thousands of exoplanets in other systems, not in the solar system, but in the solar system we detect also a lot of new planets in the Kuiper belt, for example. Here, the most common methods to detect exoplanets as radial velocity, transit, microlensing, direct images. As you can see, the transit is the common one, the most used method. And in these times, we have a lot of information from these techniques. And for this, we even taking into account that all the systems are completely different, there are no two systems equal, we can organize this detection in populations. We have hot Jupiter kind planets, cold giant gas planets, ocean worlds and ice giants, lava worlds, and the rocky planets. The thing we are most interested because the rocky planets are similar to Earth. Connected with the detection of exoplanets, we need to study the conditions for the search and detection of Earth. This is very difficult, but we must start for any step, and the step is trying to determine if the planet is in the habitable zone. It means the distance to the star for which the flux of the radiation on the surface of the planet permit the presence of liquid water. In this sense, we will talk a lot about Kepler, because Kepler is the space telescope devoted to the detection of rocky planets, Earth-kind planets. Well, as you can see here, it seems that a high fraction of stars have Earth-like planets, rocky planets, with a temperature on the surface that allow the presence of liquid water, always that you have water on the planet, of course. In red arrows, you can see the position connected with the habitable zone of Venus, Earth, and Mars. And as you can see, there are more Earth-like planets in the habitable zone. Which are the conditions to search Earth-type exoplanets in the habitable zone? We cannot put all on the same bag. We need to try to discriminate and try to be sure about how to determine that the planet there exists the possibility on the planet to have life eventually. Well, the four conditions are Kepler conditions is the mass of the planet. We need a planet capable to retain the atmosphere. We need a pressure, an atmospheric pressure, because the liquid water is not in any condition. We need a radio of the planet less than 2 Earth radius, and the mass of the host star, the host star, because we need time for life, for development of life. The increasing of the sensibility of the instruments to observe these exoplanets permit us to organize the small bodies into groups. The planets similar to Earth arrive from two sizes, the Earth and super Earth planets. You see, there is a distribution, but we have the possibility to organize this group in very specific sizes. And for this, we have several candidates, Earth-like planets, and at the distance, the right distance to be in the habitable zone. This is an example, is our solar system at the bottom, and on the top is Kepler 186. Well, you see, is a Earth-like planet in the habitable zone. The other important, very important things that we have the capability in these times to study the atmosphere of the planets, even that the atmosphere is a bit extensive, because if the atmosphere is very near to the planet, we cannot analyze the transmission spectrum. And through the transmission spectrum, we can determine the chemical composition of the atmosphere. In this sense, in this image, you can see that we are detecting the material for life, water, of course, but also more chemical elements imprescindible for life. Probably you remember this image. It was one of the images published by the Webb Consortium, the Webb Telescope Consortium last year, in July last year, when we see WASP-96b with all the signatures of water in the infrared light. Like this planet, there are a lot more. But we have exoplanets, we have Earth-like exoplanets, we have water on the exoplanets with atmosphere, with all the conditions to maintain on the surface life. But the big unknown is how likely is that life will evolve if the planet is suitable to maintain the life. It's a difficult process, the life, and once it starts, it continues. But we need to study with detail how to explain the existence of life, even knowing that we are made of the same chemical elements, and the chemical elements arrive from the stars, and the stars evolve, the stars contribute with the material to the space, and from the interstellar, intergalactic clouds, we have new solar system, new planetary system, new exoplanetary systems. Everything is made of the same material, but how these materials are organized to produce life. The origin of the terrestrial life must to answer some questions. There are three big enigmas around the life on Earth: where, when, how the biogenesis begins. About where, well, in the last decades, the biologists arrived to a consensus, an agreement, and it seems to be that the oldest traces of life are in the Western Australia. Life, complex life, is in Western Australia, in Pilbara Hills. They are dated about 3.5 billion years ago. But, however, it is possible that life existed since before the oldest era, not as complex life, but in the form of bacteria, for example. And when we ask when exactly, well, the consensus is that life was established on Earth in a period between 3.5 and 4 billion years ago. And what about how? Well, about how it is not clear that life started on the Earth planet. In fact, it is possible that the life arrived from outside, and this was produced because the exchange of rocks along thousands, millions of years, thanks to the impact of comets, asteroids, meteorites. It is a way in which protected from the external space condition, very, very aggressive, microbes could survive trapped into these rocks. And the exploration of the extreme environments give us some, we are enthusiastic about the possibilities to have life in different habitats. And in the past years, the ecology of extreme environments has grown in a big way, amazing way, because the extreme habitats permit us, has a potential to use the extremophiles in biotechnological processes as bioremediation or biommining, but also is very important to search the limits of life, which are the extreme habitats for the presence of life. And the exploration of these extreme environments connected with the search of limits of life has on Earth very important examples, like Rio Tinto in Spain, an acid environment where you have a big amount of different kind of life, Altiplano here in South America, in Chile, Argentina, salt flats with evidence, with the presence of different kind of life. Vostok, a lake in Antarctica under the ice, where the researchers are trying to determine if there is life, because Vostok is an example, a similar example than in Europe, the moon in Jupiter. Rio Tinto is an acid environment like, for example, Venus, and the salt flats in Altiplano are similar to Mars. And also, we have several studies in the periglacial regions, because in the frozen ground, there is life. And one of the worlds in our system with the most amount of permafrost is Mars. The typical condition in other planets might be very different from those we can study on Earth, but the study of extremophiles in our planet tell us about the life in these extreme conditions outside the planet. Perhaps primitive forms of life are still on Mars, and that is the reason why Mars is the planet with enormous astrobiological interest. When we talk about the first life, we don't want to see we have bacteria. No, probably the life was most primitive than bacteria, but was a link, a chain with the life as we know today. The primitive organisms may still exist or not on Earth, but we have not found for the moment on Earth this primitive life. Because of that, we are trying to find it in Mars. It's not possible to put all in the test tube and put all the chemical elements and the life appear spontaneously. No, the origin of life is an event that takes millions of years, billions even of years, occurs once on a whole planet, but once the life is started, they grow. And the most interesting thing when we study the extreme habitats here on Earth is that life can adapt to different environments, even very different of the first one, where the life was originated. No, the life can adapt for different places on Earth. just to give you another example, look at this. It's the atmosphere in a WASP-39b, also a study with data in different wavelengths, mainly from the data taken by the James Webb Telescope. There is a big evidence that the photochemistry is happening in this planet and many others, and we can make detailed models from the processes in the atmosphere, and we know that in this planet the photochemistry is active, is the interaction of the light of the star, the host star, with the atmosphere of the planet. Photochemistry is fundamental for life on Earth and probably for life in anywhere. And why? Yes, it's connected with the production of ozone, with the photosynthesis, with the production of D vitamin. In summary, the origin of life question as at its corollary, it is the existence of intelligent life is a primary focus of exo and astrobiology. The life origin is not a miracle. The life is an unusual event that can be studied from a scientific point of view with the aim of understanding how it's happened on Earth and how the life could eventually occur elsewhere. And that's all. Thank you very much.
Thank you very much, Beatriz. I think it was a very interesting speech and very connected with the new workshops that we offer, workshop 10 and 11. And I recommended that all our participants try to find the information in the website in next week or the end of next week, better. Then the next session is a roundtable that we have with several countries. The idea is to begin with the presentation, and after there is time for discussion between them. The first one is China, Dongni Shen, after India, Samir Sacheba, but maybe it's Nabil, because I saw that he was here. The next one is Indonesia, Hakim, and the next one is Portugal, Jose Dantas, that they are working together with other countries, Portuguese-speaking countries. Then I give the pass to Dongni Shen. Please, Dongni. I think he was here. I finished.
Yeah. Yeah.
Okay.
Can I share the PPT file?
Yes,
Yes, Dongni, you have permissions to share your screen.
Yeah. Okay.
Great.
Can you? Yeah.
Yeah.
Okay. Good evening. It's our night in China, and this is Dongni from Beijing Planetarium. It's a great honor to share our NASE experiences in China for the past years. Although I'm on the round table of astrobiology, but I would like to take about 2 minutes to review our NASE and let you see how NASE looks in China. Yeah, this was the beginning. I hope Beatrice and Rosa, you remember the hot summer in Beijing. Yeah, it's more than 10 years ago. Yeah, when the IOGA was held in Beijing in 2012. Yes, it's the first time we know NASE. Thank you so much. And the Chinese teachers and staff at Beijing Planetarium began to know that teaching astronomy could be so amazing. And from then, my colleagues and I keep in touch with NASE group all the time. Just a few examples. It's 2017 in Ningxia, lies Midwest of China. We had a one-day training, especially for the local teachers. Also, 2017, in Guizhou province, southwest China. That's my best group. And the background is the 500-meter radio telescope fast lights. Yeah, and here in 2018 in Guangdong province, that's the southeast of China, all the training teachers took the photos just at the statue of the Tropic of Cancer. And we selected a different region to hold NASE training each year, and we hope the teachers enjoy the course and also the different regions. And here in 2019 in Shaanxi province, that's west of China, where the capital is Xi'an, the city Xi'an, and all the teachers just found to get the certification. And also 2019 in Macau, South China, I was invited to give a special training to all the best teachers around China who just won the prize of scientific innovation that year. And this lady was very excited to promote the performance of her group, and the teachers really enjoyed astronomy learning with great fun. I'd like to mention the amazing workshop held in Beijing, also 2019. The lady is from Iran, and who is a professor teaching astrophysics in her university. But when he presented their model, yeah, that is the same as ours, I plotted to her. It's not nasty, but very similar. And for Chinese teachers in primary and middle schools who teach astronomy, one of the biggest difficulties is there is not enough easy get Chinese material. And thank you to all of you that gave me the permission to translate the NASE course into Chinese. This is the Chinese book. The cover is like this, and the title is just 14 Steps to the Universe. And which also translated all the material, the PPT, the PDF, and the Word files into Chinese all the way, just like this. And in 2017, yes, we was honored by NASE Group. Thank you. And just 4 days ago, yeah, on March 15, I was invited to give a keynote talk virtually together with another 3 teachers. The audience were teachers from all around China. The topic was focusing on how to teach astronomy in primary and middle schools with the help from observatory and the planetarium. I do believe it was the best opportunity to promote our third event, Bridge Between Cultures. Many teachers were interested in our project, and I do wish many more teachers could complete our project before September this year. And astrobiology and meteorites. And I myself think it is the most charming theme for both students and teachers. As a curator, my colleagues and I presented an exhibition themed as Looking for Another Earth, and in Beijing Planetarium. Also, we have a full dome show named UFO and the Aliens. Both are welcomed so much by children. And also in 2022, we brought part of the exhibition to the National Science and Technology Week, let the children to design their alien creatures by drawing. This the children's drawing, and it was the most crowded booth, yeah, among our exhibitions. And when possible, I would give a talk themed Looking for Another Earth. Yes, and it's obvious that students love astrobiology very much and are always fascinated by UFO, aliens, and so on. And astrometeorites. This is we call it Nandan iron meteorite, just in Beijing planetarium. Yeah, here there are lots of the fragment of this same iron meteorite. Yeah, it's just a very teeny fragment. I'm optimistic about our new NASE course in 2023. I think astrobiology and meteorite would be the most charming theme for students and also for teachers. Okay, that's all. Thank you, and looking forward to see you all the better face to face. Thank you.
I hope that. I hope that. Thank you very much, Dagny. The next speaker is, in this case, from India. I don't know if Samir or Nabeen, because...
Am I audible? I am there.
Samir, hello. Yes. I didn't see you before. Yeah, sorry. Yeah. Then, do you like to share with us your PowerPoint? And Dagny, could you remove your PowerPoint, please?
Yeah, sure.
Okay, thank you.
Let me share.
Thank you very much.
Okay, it's really a pleasure to be here speaking on behalf of Spaceport India and India in particular. My team members are also there. So basically, we just started everything 2 years ago in 2021, I guess, wherein we were having an informal interaction with Rosa and Beatrice. And we just, while discussion, we found that yes, there are some common interests wherein we both want to promote astronomy in India, because India is a huge country wherein there are different multi-language speaking guys, like Hindi is there, English is there, some don't even understand English. So a lot of local languages are there, so a lot of impact is there from Indian perspective. A lot of different cultures are also there. So our team, I introduced everyone to Rosa initially. So I am here myself, Naveen is there, Karthik, Nirmal, Varsha. So we all took this as a responsibility to represent India along with NASE on this platform. So because astronomy in India is always looked upon as a kind of a hobby, always. Since day one, when I have been into, since my childhood, I would say, there are not much career perspective, only teaching is there, or explaining things, and just curiosity is there. But in terms of jobs and in terms of actual research work, now things have started changing. A lot of things are going on, but again from job perspective, not many things are yet to be done, unfortunately. And there are many schools in India which don't even have privileges.
Samir, it's possible that you speak close to the micro.
Okay, sorry, my bad. Sorry,
to listen you better, okay?
Okay, sure. So when we started, we were just having few teachers who are based out of private schools or public schools, which are government based in some villages. So in villages, we have a lot of challenges with respect to sending out the material or asking teachers to arrange materials for themselves and for the school kids. So it becomes very like if I take an example like globe, the globe in itself, or some of the materials, right, or even foil paper is there. So these things are not used in villages. So that's the biggest challenge. So what we did as an initiative, we planned everything in advance, and we started conducting the NASE astrobiology, astrophysics, and astronomy. And then we used to supply them free of cost whatever material is required. Or we used to ask them, okay, if you are not able to get this particular thing, then use this. What is there in your household? So main purpose is to keep it very simple and at a very basic cost. It won't cost you a fortune or something like purchasing a telescope or something. So that was the main purpose why we were really interested in conducting these classes everywhere across the country. We are growing, but it will take some time, because astronomy is something that is given least priority in India, to be very honest. Hardly a few people are there who can afford telescopes and do something about it. So these are some of the materials which we have been collecting and providing or packing them or doing something. Some part of it, and whatever printouts have been given, even printouts also sometimes we have to actually send via package as a parcel to the various school kids and school teachers. So I mean, last year we did some experiments. Obviously, now we will be more proactive. So that's what we have right now. So astrobiology in specific, if I talk about, everyone has been really very curious. Each and every session, even teachers want to know how the humans or even the animals originated on this planet. Why there is life only on this planet? Why microbial I mean form is there but not the alien form like in human shape, or it could be anything. And obviously everyone talks about movies and all, so how realistic it is. Like many of our team members are talking about exoplanets also using NASA content, and everyone is fascinated, oh there is something outside way beyond our solar system also. So lot many things are changing. It will take obviously some time, but that's what we just started in 2021. So obviously we don't have that much of I mean content or discussions, but yes, remotely we are taking lot many sessions. Okay, so these are some of the, I mean I just thought maybe sorry, some noise is there. Okay,
Well,
so
Medar from Togo, could you turn off your
I
microphone?
will, Rosa. I will take care.
Okay, okay.
so I just thought maybe I will just add this collection. I mean, this is just a small one. I do have others. So basically, this is what we use in our asteroid day or any other events wherein we just go over there and we explain to them via these real ones how things are working and how meteorites fall, what are meteorites, difference between asteroid meteorites, or what they could, even substantial things they can carry in themselves, like life form, or it could be anything. So a lot of things are there to be, I mean, explored with the help of NASA course, and it is really very, I mean, whatever content is there. I mean, I haven't seen such a detailed thing anywhere else. Whatever teaching I have been involved in, or my team is involved in so far. So a lot of things are there which are really well explained, whether it is mathematics or theory or videos are there. Rosa herself has done a lot of effort. So I mean, this is really wonderful content, what I feel. Yeah. So that's it from my side, Rosa.
Thank you very much. I would
Thank
like to mention that they are teaching in India in different languages. They are using English and Hindi also.
Yes.
And after they are planning to translate to other ones. Thank you very much,
Yeah. Thank you.
Samir. And I would like to open the session to Hakim, Indonesia.
Yes, thank you very much, Rosa. Hi, everybody. Let me share some points from Indonesia, especially on NASA, but with regard to the astrobiology activity to address this issue that we are going to discuss today. So first of all, of course, let me introduce, I'm Hakim Malasan. I'm the coordinator of NASA in Indonesia. And just to give you a brief look of Indonesia, we are comprised of 3 time zones, yes, stretching from west to east. And just want to make a short advertisement that next month on 20th of April, there will be a total solar eclipse in Timor-Leste. So I hope you will be able to enjoy that. So we started the IAU NASA since 2016. And when we deemed that training the science teacher in the secondary level of education is indeed indispensable and very much needed by such a big country like Indonesia, because of a bigger gap of education quality between among the big cities and the remote areas of that. So it was started in 2016. So if you like to see how Beatrice look and Rosa look in back in more than 10 years ago. So they thanks to them, because Rosa, Beatrice, and Akihiko came to Indonesia and met my colleague, Professor Kunjaya in Machung University. We started the NASA training here, and it evolved very quickly. In 2018 and 19, a university in Lampung hosted this event. And it was a very lively event because participated by many teachers who are very much enthusiastic in trying to deliver astronomical course in the easy way to the students mostly. in 2019. Of course, yes, a NASA trainer from England also came to Indonesia, engaged very much, and also we extend actually the activity to rocket competition. But none of them actually touch upon this situation of the astrobiology. So in 2020, for the first time, we did this NASA training in virtually. It was participated, of course, by more than 100 participants for the public lecture. But for the selected teachers, we selected actually 30 active participants in all this. So the slides show you how the workshop actually conducted virtually. This is the first time maybe for Indonesia to do that, but we found that even the observation can be conducted very successfully on that time. So one telescope is situated in the western part of Indonesia, and all the image was streamed to most of the participants all over Indonesia, and all the servers were put in Bandung city, and we did it very well on that time. So speaking about the instructor, this is the number of, this is the people who help us very much. Most of them are very young lecturer from mostly mathematics science faculty at that time. So then when we go to this astrobiology case, let me give you a bit introduction that none of this astrobiology touch upon the curriculum in the elementary and middle education, because most of astronomy parts in the curriculum address mostly on Earth, Moon, Sun system. I think because this is very much dictated by Indonesia, which is mostly Muslim, and we try to, of course, educate the young people at the very beginning on how to look at the crescent, how to actually start the praying time and something like that, that related to Muslim activities. Then actually astronomy is also supplemented by many education outside the classroom, in which a planetarium is one of the facilities among many. And of course, we have several astronomy observatories, but not so big one. The Science Center is also a very interesting place where mostly young people gather there. But we found that for large archipelagic country like Indonesia, communication is very important for this. So that's why there are many online astronomy educators and communicators actively promoting astronomy, including astrology. Oh, sorry. Can you hear me?
Yeah,
Hello?
we can. Yes, we can.
Oh, yeah, thank you. So the only thing that exists in the higher education is a course, which is 2 credits for a master student in ITB, and also for undergraduate students in ITERA, in the Institute of Technology Sumatra. So this course actually touch upon the very formal course on astrobiology, such as discovering many aspects of life of Earth, searching for just a minute, searching for life in the universe, searching for life in the perspective of exoplanet, habitable zone, SETI. While in the master course, of course, we try to pursue this in the multidisciplinary way, in which it incorporated astronomy, biology, geology, chemistry, and development technology. So the curriculum is actually, the syllabus is actually comprised of a quite comprehensive one, but mostly delivered to master students. So the outcome from this course, a formal course in the university level, of course, is to address this issue. Students understand the questions that are we alone? Questioning the meaning of life that so far only found on Earth. A student apprehend important elements or characteristics of life on Earth and how they evolved during the Earth's history. And students apprehend various aspects of life searching in the solar system and elsewhere. And students understand the motivation behind the search of intelligent life and various aspects performed so far. So the point is we try to actually disseminate this to the wider public, but of course the means is very important, and I think NASA may play a very important role in helping us for that. So among the graduate students in ITB, of course, there is a very quite frequent discussions among them. For example, some students actually address mostly not on the not on the life on the universe, but mostly on how exobiology means that how to sustain life at the zero gravity, monitoring resident space objects and space sustainability. And yes, in the informal education, there are many initiatives by BRIN. BRIN was the Indonesian former NASA. It calls LAPAN. So they regularly conducted several public outreach with regard to biological experiment outside in the outer space. And there is also many talks, of course, initiated by langitselatan.com, which is a very prominent science communicators in Indonesia. So, of course, they work together with us to spread, of course, the knowledge about the astrobiology. And there is also a teaser video, for example, here showing you that this is an appealing one, actually, because we try to attract as much as possible young people to, of course, discuss the issue or address the issue about life beyond the Earth. And this is conducted in, I think, once a month through, of course, the social media. And of course, it's very much interested by the young people here. So at the end, I would like to, of course, show you how high school students' participation in KIBO. KIBO is actually a Japanese experimental module that is, of course, set up in the International Space Station. And they, of course, call for any research program that can be conducted by high school students. And it is really rewarding for us to see 5 of our students' team are participated in the KIBO experiment, and at the end they make a very nice presentation on mostly on microgravity experiment and environment simulation. So that's all I like to tell you, and of course this is very interesting for Indonesia to participate in the NASA, including the astrobiology. Thank you very much.
Thank you very much, Hakim. I would like to invite the last speaker of this roundtable. I would like to ask if it is possible that you only speak 5 minutes, because in other case, it is impossible to continue with the program in a good way. Jose Danas from Portugal. Dantas, sorry, Dantas.
I'm
sorry.
Dantas, exactly. I'm going to be faster, I hope. I'm going to share my screen.
Yes, please.
Are you seeing now my screen?
Yes, we can.
Okay.
Yeah, perfect.
I'm going to say first some difficulties we faced during the online teacher training to Santo Tomé Príncipe, Brazil. We have teachers from these countries: Santo Tomé Príncipe, Brazil, Mozambique, and of course from Portugal. Sometimes the internet was weak and failed. And this online format made it harder to understand if the teachers were following the course and if they were comprehending what I was saying. Sometimes the camera were not on, which made it hard to understand how many teachers were actually attending the course. Sometimes some teachers was actually talking on the phone. In the beginning, the conversation was mostly one side, very little interaction for many of the teachers. At the times, no one posed questions, and I feel I was speaking alone for a long time. At some point, I posed some questions to force interaction, and it became better. Even though the language was the same, Portuguese, there was a bit of a barrier of communication due to different accents that were hard for me to understand. The time difference was also an issue, which was more severe. In the case of Timor-Leste, we started at 9 a.m. in Portugal, which was 6 p.m. in Timor. The plan is for Mozambique had to be appropriate for South Hemisphere, and the ones for Timor has to be for equator, near equator. Sometimes the condition of living of some teachers in this country was not the best, and that's why the internet was also not the best. And could we see through the camera during the course? but the teachers in general was very happy and grateful to have this opportunity to interact with people with other countries and to learn some scientific knowledge from astronomy. The feedback overall was very good from all the teachers. After some time during the courses, the teachers would open up more, be more easy to pose questions, and then interact with me. They got to have the opportunity to discuss certain topics. They made doubts about what they had no other way to see and explain. The teacher were able to produce almost all the materials that we are requested and would happily and proudly show them to the camera. You can see in this image. I can show you more images of our work. And you can see they are happy. They like it. They like it very much, and show everything they produce. This is from Mozambique, and most of them are from Timor and São Tomé e Príncipe. Here you see the smile of them. I think they like it very much at the end. I finished my presentation.
Thank you very much. Thank you to control very well your time, because in other cases it is
I was very fast.
We are late, and then I am sorry, but I cannot give time for discussion. Then I will pass to Ricardo Moreno, to my colleague from Spain. Ricardo is member of NASE, well, is one of the main important people in NASE. He is the secretary. This is a very important in my country. I don't know in yours, but that means that he controls many things, and I am sure that he controls very well the time. Then I would like to introduce him because he will talk about the new project of NASE this year, okay? The UNESCO project looking for meteorites. Then also he will pass one short video at the end of his speech, okay? Then when you want to share with us your PowerPoint, Ricardo?
Sí, okay.
Tienes que darle al botón verde de abajo.
Sí, okay.
Yes, excellent. Thank you.
Okay.
Good.
I am Ricardo Moreno from Colegio Retamar de Madrid, Spain, and NASE, of course. I'm going to talk about the look for meteorites. As you know, every day 5 tons of outer space dust falls on Earth. It consists of small rocks, mostly made up of fine grains, which, when entering the atmosphere at high speeds, 30,000 kilometers per hour, approx, melt by friction, and some can be seen as shooting stars. These rocks or grains originate from the very matter that gave rise to our solar system. Therefore, they are around 4,500 million years old. This fine material falls on Earth everywhere, including housetops and roads. Rainwater washes it away, so a good place to look for it is in road ditches and roof gutters. Its rounded and grooved shape reveals its passage through the atmosphere. Here. Most of these meteorites have a rocky composition, but others are made of iron and nickel and can be separated from the rest without magnet. In NASA courses, we use the following procedure to collect them. Firstly, with a brush, some sand is collected from a ditch or a gutter. Then, a small amount of sand is put on a piece of paper and a magnet is passed under it. As we do so, we observe that some particles move, attracted by the magnetic field. Without moving the magnet away, we turn the paper over, and we are left with only the metallic and dark material. It's important to always keep the piece of paper between the potential micrometeorites and the magnet. Although we identify micrometeorites, we can inspect the material with a camera on a mobile phone using maximum zoom. Micrometeorites can be identified because they have a rounded, spherical, and brilliant shape, like small dark pearls, which tell us about their fusion and subsequent cooling when passing through the atmosphere. Here. Let's see this video, which we use in NASA courses. We collect material from street gutters and ditches with a brush. We keep it in an envelope. We collect more material near trains. And now we are going to separate the metal pieces. We first spread out a small amount of sand. With a magnet placed under the paper, we separate the metal pieces. We throw away the rest. You are left with only the small, dark, metallic grains that are attracted to the magnet. Another one. Here the micrometeorites, possible micrometeorites. The metal piece moves. There should always be a piece of paper between the magnet and the micrometeorites. Here. Now we examine it with our mobile phones camera using the maximum possible zoom setting. Those little shiny dark spheres are micrometeorites. The material has melted upon entering the atmosphere, and the droplets have solidified before reaching the ground. There is another one. They look like shiny and dark pearls. And then we have another one here.
Ricardo, you only use your camera in the mobile.
Yes,
The
yes,
optics,
yes.
only the camera.
Only my camera, only.
Yeah.
The formation of these spheres, as they pass through the atmosphere, can be simulated by heating chocolate milkshake and orange juice and adding the thickener such as agar. It can also be made with the gelatin obtained by cooking several chicken legs. Here. Using a syringe, liquid drops from the result of these processes can be dropped into a tall glass with very cold oil. It must be previously put in the freezer for at least 30 minutes. Solid spheres are then formed and accumulate at the bottom of the glass and can even be eaten. Let's see all this in a video, which we also use in NASE courses. Remember, we prepare the mix of chocolate or orange juice with a thickener of the agar type or with gelatin from chicken legs. We place some drops of the mixture into very cold oil. As the drops fall, solid spheres are formed, which accumulate at the bottom of the glass.
It's a simple way to explain why is the reason that meteorites, that micrometeorites that we catch are spherical.
The girl will say, these spheres are edible. And the little Frank will say, and we eat them. These are the spheres obtained with chocolate and orange, and this is a real micrometeorite.
Okay. Thank you, Ricardo. Thank you very much.
Okay.
You can see that it is a serious project, but very funny if you want, of course. Well, thank you for your presentation, Ricardo. And the next speaker now is the group of micrometeorites. I have here the list of countries that will participate. There are many of them. And I insist that please only 5 minutes, okay? We have Ivo Jokins from Bulgaria, from Ethiopia, Biruk Terefe, from Egypt, Magdi Atia, from Romania, Corina Toma, and from Tanzania, Norali Jivaji. Then the first speaker is Ivo Jokins. Ivo, are you ready?
Yeah, are you hear me? Thank you.
Yes.
Thank you, Rosa. Let me share.
Please share your PowerPoint with us.
Yeah, and let me share my presentation. Okay. Can you see?
Yeah.
Okay. So let's introduce myself. My name is Ivo Jokin. I am Director of Municipal Center for Extracurricular Activities and Physics and Astronomy and Chemistry, Biology teacher in this municipal center to inspire students through the study of meteorites and micrometeorites. Here is my working place, exactly in River Danube, municipality of Dolna Mitropolia, Bulgaria. Here is my municipal center. We have an Astro Club, a painting club. We organizing a different science camp, special science camp. We have accommodation and great activities with students. we organizing in this February 2023 NASE online course astrobiology with great interest, with more than 100 teachers from Bulgaria, with lecture Rosa and Corina Lavina Toma and Paula His and Ederlina Vinuales. So it was a really great workshop with topic astrobiology. 2 days, including very interesting workshops and lecture, and also observing session with remote telescope in Rosen Observatory. We observed comet C2020 ZTF. So thank you, Rosa, again for this opportunity for Bulgarian teachers. Let's introduce which meteorites fall in Bulgaria. In Bulgarian territory from the 18th century until now, 6 sure falls of meteorites are known by written evidence or a concrete object in museum collection. Most of them are stored in the meteorite collection in the Museum of Mineralogy, Petrology and Minerals of the Facility of Geology and Geography of the Sofia University. They will present it chronologically by the date of their fall, but I would like to show you, this is Belogradchik meteorites. The meteorite fell in the area of this famous area in northwest part of Bulgaria, in very small village of Verba, on May 20, 1874 year. The first publication about the Belogradchik meteorite is from this year by the professor of geology Gabriel August Dopf, and the description of the rock is given by Wolf Fleet. He writes that the meteorite fell in a strong stream, driving into the ground at a depth of 1 meter. He is
Ivo, I have a question for you. We are looking all the time the same first slide. This is correct, or do you like to pass?
Yeah, this is evidence. This is from authors, and
Ivo. It seems that you are not present in the PowerPoint. We are just on the screen. Yes, stop.
Only the
start
first
again.
one slide. Yeah.
Okay. Here, maybe here is visible like this.
Yes, it's.
Okay.
I think it's the third one and the fourth. Yes, okay.
Yeah,
Ivo, it's okay.
maybe this will be okay. Here is a map of Bulgaria. Yeah, where fell this first. It's the biggest meteorite in Bulgaria. Okay, I explain. And first publication about the Belogradchik meteorite. The first publication is from Gabriel August Dobry in this journal. This announcement was immediately references in the 10 and How Famous Nature, August 13, and Chemical News, September 1874 year. The Verba meteorites belongs to the Sporadosideres group from the Oligosideres sections. It refers to the most common type, such as the Lucite meteorite, Sartre and department in Northwest France. Okay, 3 pieces of the Verba meteorites in London, you can see, and 1 piece in Budapest, now located. This is a meteorite which is stored in the My Municipal Center for Extracurricular Activities. These meteorites give me my friend in north part of Africa. I think is Morocco, from Morocco. Okay, and students very happy to bring in your hand. So we use it different activities and approach. Here you can see micrometeorite straps, required materials, very simple, cardboard, just cup, twin or string, a small magnet. we put magnet in this paper cup. Another for traps, aluminum tray for baking sweets, and house a whole plastic wrap. And just before today, I finished science camp with students from Municipality of Dolny Mitropolia. Students really very happy to make these activities. They move around the schoolyard area with a magnet cup and then remove the magnet. And if there are iron particle, micrometeorites, they will fall into the white sheet of paper. Students observe with their phone camera to find micrometeorites. They are small, really sphere. Okay. Thank you very much for your attention.
Thank you, Ivo. Thank you. I would like to pass to the next speaker, please. Biruk.
Hello, everyone.
Hello, Biruk.
Hello,
I'm sorry, I write badly your name, but I know it when you are Biruk.
No, it's all right. It's all right.
Sorry. Okay,
No,
do you want to share a PowerPoint?
Yeah, yes, of course.
Okay, please.
I have a small PowerPoint presentation, yeah.
Biruk from Ethiopia.
Yes, can you see my PowerPoint? Yeah. Yeah, so my name is Biruk Tarafa. I am from Ethiopia. I'm the managing director of the Ethiopian Space Science Society. We do several outreach programs and several programs to engage students in Ethiopia. So our goal is to make Ethiopia a scientific society. We basically teach high school teachers and students about science, about space, about astronomy. We use different tools and materials in order to fulfill our goals. I would like to thank Rosa and everyone for inviting me here, because by using this experiment, we could teach so many teachers and so many students in different schools. So I would like to show a bit of what we have done in order to prepare for this presentation. So what we basically did is try to identify some micrometeorites, and we have a rooftop here. Our office is on the top floor of the building, so we have a rooftop here. So we collected samples from here. You can see my PowerPoint, right?
Only your logo, no more.
All right, okay. Let me go. Yes. So how about now?
Now table of content, yes.
All right, thank you. So I'm on track.
Etc.
Yeah, so we used the three steps that were recommended: the collection, the separation and identification, and the research work. So in order, so what we are seeing right here is the Ethiopian font of our motto: Ethiopia shall become a scientific society in the Ethiopian words. I was supposed to bring it upstairs. Anyhow, the first step we did was the collection part. So we collected the sample from the rooftop. Since it's rainy season in Ethiopia right now, we have a rain. So it's easier for us to collect micrometeorites from the gutters and the rooftops and everything. So the sample we collected has water in it. So the next step we went to was the separation step, the separation and identification step. So in this process, we dried out the sample by using we poured the sample in the water so that we can dry it out, and we let it dry for a few hours, and we have a dry sample here. So in order to identify the metals from the other particles, we used magnets as recommended in the paper. So here is after this, we went to the research work. So it was suggested that we can use our phones to identify the micrometeorites. We tried our phones, but we also added some lenses we have in the office so that we can have a better magnification. So we combined our lenses and our phones just to identify particles. So we're basically doing the research part, the search part right now to identify the spherical meteorites from the other metal particles. Now we have identified the metals, and now we are trying to identify the metals. So here is what we are doing right now. So basically, this identification of micrometeorites it means a lot for us, because when we do outreach programs, we can teach the teachers in different schools to teach their students this technique so that everyone can identify micrometeorites easily. It was helpful. I would like to thank everyone for this chance. And also, I would like to let you all know some recent incident that occurred in Ethiopia regarding the meteorites. So the next picture I'm showing you right now is some meteorite incident we had a few months ago in the southern region of Ethiopia. Mm-hmm. So actually, it wasn't micrometeorites; it was just meteorites literally falling off on houses and burning of crops. So what we are doing right now, this presentation and this educational process, I would like to let you all know how much value it has, because this incident created a national attention, because people were literally connecting the incident with religious views, because they were literally seeing a fire coming from the sky. They can't identify meteorites because it's a rural area in Ethiopia. So what we did was we tried to engage the public through medias and mass medias and the social medias, and try to create awareness and let them know that these were just rocks from space falling down onto houses and crops, not some punishment from God or something. So using the experience we have right now, identification of the micrometeorites, we can also create more awareness in the rural areas by going to schools and teaching the students and teaching teachers on how they can identify, and we can do a lot using this. And I would like to thank everyone for your time. I'm not going to take much of time after this, and you can support ESS, support our endeavor. Thank you.
Thank you very much, Biruk. And I would like to give time to Magdi Atia from Egypt. I don't know if I pronounce correctly.
Hello, everybody. Thank you for the invitation.
Excellent. We can see the video.
You can see my screen. Do you see my screen?
Yeah. We can see the PowerPoint.
Yes, we are seeing your WhatsApp, in fact.
Okay.
Yeah.
This is WhatsApp.
Yeah.
Hopefully it's in Arabic.
Yes. Okay. My name is Magdi Atiyah from the National Research Institute of Astronomy and Geophysics. Okay, we have two main branches at my institute. One is for astronomy and space sciences, and the other main branch is geophysics. Of course, its branch includes different sub-branches. I am a geophysicist, so I am far away from your interest, but we have many researchers collaborate from astronomy with geophysics, and from geophysics collaborate with astronomy. And finally, we knew that the earthquake prediction is somehow related to some actions happen in the sky, like moonlight and magnetic storms and so on. Now I am the director of the regional center at the New Valley. It is a small representative for the main institute at Hilwan. The regional center for at the New Valley is here. This is the map of Egypt, and it is somewhere here. This is the. Actually, it is a big one, and try to activate it to make it active. This is the main building. We have a small garden and bathing rooms and some toilets. So if you decided to visit us, you will feel comfortable. Okay. What I'm doing here is, as usual, one of the main activities of the NARIAG Center is to identify the start and end of Islamic dating, Islamic months. So also to follow the sun ray incidents to the temples, like that. Okay. Yes, please. Yes, please. Come, please. Have a seat. Welcome. So this is one of our activities. It will be very short and maybe strange for you. These are some sports come to my center to get training for how to use telescopes, what is the sky, what is the ground, what is the earth, and so on. Some educational and cultural presentations for them. Okay. Now for Hawaii, actually I knew about this meeting just yesterday, and it made my intendence to investigate for the meteorite farm at Sahara Desert. I show you some signatures at the desert, which we can simply, easily prospect using geophysical tools, like magnetometry, like GBR, like maybe gravimetry. So the changes happen during the collision of the sky bodies with the ground can be detected by geophysics. Of course, besides such signatures with wide areas, you can find micro meteorite. We did some experiments at Camel, and it has been published in Nature. I don't know if it is Nature or Science, but it is published in one of the biggest journals. So this is one of my intendings to do at the center here, is to investigate the meteorite farm at the Sahara Desert. Maybe if we go back to first map this here, to see this, one of the images I show you just now is, and we knew about many places of possible existence of meteorite. The problem is such places are very hard. It's situated in the deep desert, and it is difficult to go there with normal cars, even if it's 4x4. It requires special cars for safety. Second target is to construct a museum for the meteorite storms. Many people, you know, the people who would like hunting go to this desert to hunt animals. During their back journey, they get storms with them. And we also can, if we got some such nice cars, can go there and also other stones. So I would like to construct a museum for such stones. The last is to construct an observatory, a telescope observatory at Abu Tartur. We did Abu Tartur. This is about 40 kilometers northwest from Karga. And we did already site selection and our site investigation, and we find it well. So why I am here? I am here to look for partnerships and collaboration to share us these targets, to help us to reach these targets. So we need funding and sponsors, even through or research projects. Years ago, I got an idea to build an educational and cultural center at Kharga with some other nationality, but I didn't get succeed. So I will be happy if I get this center established. So that's all. I'm sorry. I'm geophysicist. Thank you very much.
Thank you very much for your presentation, Magdi. And I would like to give the opportunity to talk to Corina. Toma,
Okay.
you want to share with us your PowerPoint, Corina?
Yes.
And please control your time.
Of course.
Thank you.
How to magnify? Only to present this? Sorry, I don't. Do you see the presentation?
Yes, the PowerPoint.
And okay. I don't know how to put full screen. This is.
It's not in full.
On the bottom?
Yes, it was on the bottom. Ah, it's under the black part. Sorry. It's very interesting. Now it's okay.
Wow.
It's okay.
Yeah,
This?
it's okay.
Sorry.
Excellent.
Looking for these micrometeorites, it's meteorites. It's a very interesting subject for me. I'm Corina Toma from a very old town in Romania, Romania one. And why I am so excited with this project, because many years ago, about 2014, Rosa M. Rose came in Cluj, and she had taught here the first NASE course. And then I became also instructor in NASE courses, because I like very much this kind of courses for teachers, physics teachers, and also for chemistry teachers, and now for biology teachers also. And in my experience, I taught about 40 workshops, 40 times workshops in different countries in Europe, Asia, and Africa. I saw that also the workshops are very important, but I participated with my students in 3 projects, NASE projects with IAU and UNESCO. The first one was the power of the sun and how to measure it. The second, the Herschel family, and the last, latitude for traveling and navigate. What I observed, that every project has the same characteristics. There are based on very smart ideas, simple to do, cheap experiments because there were not expensive experiments to do with students, but the great gain was for the students because they could enrich their scientific knowledge. Such a project involves, in my opinion, a theoretical preparation, then to carrying out the experiment and at least, but not the last least, to present it. When a student is asked to present what he has done, the problems begin because the students usually don't know how to present their work. Even a project looks very simple at the first glance. It can be done in various ways, and students can enrich it with a lot of knowledge and also a lot of practical work. For example, first time when I, as teacher, as physics teacher, I saw that in our sun, the last heavy chemical element is the iron. I was very astonished also. And then when you see here is Beatrice, I think, with a simulation of a supernova explosion in workshop 6, I realized that there are, in nature, there are big fusion reactors different than the stars because the explosions of supernova. And in the NASE workshop 10 with astrobiology, when I present it to my students, they were very happy to make the experiment with the objects with different elements from different, how to say, origins. And when I told them that we are made by stardust, they were very, at first, very, they said, why, teacher? And they understood after the lesson. And also, I like very much in the astrobiology workshop, the problems with the conditions of habitability for exoplanets, and also the experiment with the life in extreme condition with yeast and so on. For the new, for this new project, I didn't do it yet, but because I'm retired, I will use a cube space in my town. It's a space for STEAM education, where you can see we have all facilities and also some microscopes. And what I want to do in the next 2 weeks, it's a workshop in 2 sessions. At first, I want to make the theory for meteorites and some astrophysics, because I think it's normal to explain students why these meteorites can arrive on the Earth, and then to present what the students have to do. Also, I like the idea with simulating edible micrometeorites, and also of course, every student will have everything for the next session, instructions for the collecting materials and so on. And in the last session, the second session, they will come with probes, and we can analyze them, categorization of micrometeorites, because I think if we will find some nickel or other metals than iron, it's okay, and make a macrometeorites archive and also the conclusions. And I want to show you very shortly a very big meteorite which was falling down in 1882 near Cluj. And this big part, about 36 kilos, it's in the museum here, a museum of geology to the university. And this is a stony meteorite. We have materials to study with students also in this museum. And thank you for your attention. You are mute, Rosa.
Thank you. Sorry. Thank you very much for your control of time, Corina. And I would like to offer the time to speak to Jivaji from Tanzania.
Yes, I'm
Jivaji,
here.
hi. Do you want to
Hello.
share with us your PowerPoint?
Okay, so I don't have a presentation.
Okay.
At the moment,
no problem.
I'll be describing some of the things that we have here. And my name is Norali Jivaji. I am a physicist, senior lecturer in physics, teaching physics, as well as doing research in astronomy, astrophysics at the Open University of Tanzania. And I'm also heading the Astronomy and Space Science Association of Tanzania, where we have a lot of people in WhatsApp group where we share a lot of material, and especially such activities which we are talking about today. I would like to thank Rosa for inviting me to participate in this workshop, and especially because, in Tanzania, we have one of the biggest meteorites in the world, the sixth biggest meteorite. It's called the Mbozi meteorite. And there's a lot of interest in trying to understand, because it was hidden, it was buried, and the local people were doing their cultural activities around the point where it was coming out from the ground, a small part. So when the Germans in 1930, they saw that place and they were able to dig it out, and now it is on show. I'll put it on chat for people to see on a website how it is. So there's a lot of interest in meteorites, especially because this is 16 tons, a huge piece which has fallen from Earth, from sky, and it is amazing that there's something like this can happen. There's another interesting meteorite here in Tanzania, which has become world famous, called the Ivuna meteorite, and it is a small piece. It was just about half a kilo or so, but then it seems that it has been taken away a long time back by some private people, and recently it was about a few years back. It was bought from a private collection by the museum for an extremely, so several $1 million. So it is one of the oldest sources of our solar system object. So there's a lot of interest in meteorites, and there is a geological museum in our capital city in Dodoma, where they have a few other meteorites also displayed. In terms of now, perhaps this activity, we just have received this. It is something very new to me, and I'm also surprised that it could be easy to find micrometeorites, especially, and this will be a very good activity for people to participate, because we have already participated in the Herschel experiment project, the latitude travel and navigation, very successfully. People were able to follow it and get some results. So I hope that we'll be able to encourage now to present this to our group in astronomy, and get some of the students, the teachers and the students to do this project, so that we can participate this international. Thank you very much. That is what I have.
Thank you very much, Jivaji, for your participation and also for your work, your excellent work in Tanzania and translating to Swahili the NASE materials. Thank you very much.
I can add perhaps.
Sorry?
I can add that we have done NASA training. Rosa was here in 2019. She really inspired us a lot, and we continued with online training for a couple of years. Now we are planning to do another one again this year. Thank you very much, Rosa.
Thank you. And I would like to give the opportunity to Margarita Metaxa to introduce again, some comments about the NASE project. And please, Margarita, if you could reduce a little bit your time, because we are very late.
Okay, of course. So let me share my screen.
Yeah.
It's okay now?
Uh-huh.
Okay. So, looking for micrometeorites, another pioneer project by NASA that is driving us to innovation in astronomy education, and finally lead us to the science literacy. So I'm sure that most of schools in Greece will go and collect in sites where waters has been drained. We'll collect the dust in a very simple way that other colleagues have shown. We'll separate all this dust with a magnet, so to leave all the iron particles, and then by identifying the spherical ones, we'll conclude that we have collect the micrometeorites. And we will be sure that these will be micrometeorites because of the process that they are created when all this material is melted and then solidify again in the atmosphere. That's why they really have a spherical shape. So afterwards, of course, we can simulate edible micrometeorites and then, of course, eat them, as we have seen. This is a very simple way to get extraterrestrial material. It's an excellent introduction to astrobiology that NASA courses offer. They can motivate students and teachers, and of course all participants to probably another event, another window to the universe. So at least in Greece, we will sure promote it. It's a challenge for colleagues that are creative, innovative, and enthusiastic. And we welcome this new NASA family project, and we are sure that will have a great impact in our countries. Thank you very much, NASA, Beatriz, Rosa, and all your colleagues. Thank you.
Thank you, Margarita Metaxa. I kiss you because you control your time and you reduced our situation that was very late. Thank you very much. Kisses, Margarita. And the next speaker is Alejandro Lopez. He's from Argentina. He's an expert in astronomy, but an astronomy from a different point of view than normally we use, because we are interested to open also this session to the meteorites that was found, and what is the history of these meteorites that in some cases arrived to us after a long process, that in some cases not very, how do you say it? Not very positive, okay? Then Alejandro gave us a special different session, but I think that it will be very, very interesting for us and offer us the opportunity to learn many things about these special situations for some meteorites. You know that in Argentina there are many Campo del Cielo, there are a special meteorites that there are a lot of them in the territory. And of course, probably there are a lot of very interesting histories. Thank you, Alejandro, to help us and to participate in this session.
Thank you. I try to be quick in my presentation, but this is not easy.
Thank you.
You can see the presentation?
Yeah.
Perfect. Okay, I am Alejandro Lopez. Thank you for having me here. I'm astronomer and anthropologist, and I work in cultural astronomy for many years. I talked to you about the Campo del Cielo meteorites and the Mocoit people that are Aboriginal people that lives in the region of this meteorite dispersion in the northern part of Argentina. And I'm working with these Aboriginal people from 1998, especially about the cultural implications of Campo del Cielo meteorites. And you know, these meteorites have a very long history of relation with human populations. We know about these relations almost from the colonial sources, but some archaeological evidence that tell us about a very, very long time relation among human people and meteorites. And this is a specific region of the Campo del Cielo sky field, this meteoritic dispersion. And these are some of the main features of the dispersion. Are metallic meteorites from maybe 4,000 years ago. It's a very long dispersion, 100 kilometers for 3 kilometers. There are 26 craters and many metallic fragments. Some of them are some of the more biggest meteorites in the world, the second, the third. And as we talk now, they have a very long cultural history. We have these very old ethnohistorical records of relation among Aboriginal people and meteorites, and also a lot of colonial expeditions to see some of these meteorites, in special a very large one of around 20 tons, the Mesón de Fierro, the very large table of iron that is now, we can have this fragment now, is lost in the 18th century. This is the last map of the location of this meteorite. But we have a replacement for this very large piece of meteorite, that is this meteorite, El Chaco meteorite, from the same dispersion. It's this meteorite have 37 tons, and is a kind of new icon of this meteoritic dispersion. And it's viewed as the other metallic meteorites in this region by the Aboriginal people as a powerful object linked to climatic conditions and a very important feature of their territory. You have here another large meteorite from Campo del Cielo, the Gancedo meteorite, unearthed on September of 2016. And also some key remarks about the importance of this meteorite for the Aboriginal people. first of all, are considered as sacred landmarks of the territory, and as the presence of powerful beings from the sky on Earth. And for Aboriginal people, the manipulation of meteorites are connected with the manipulation of power, luck, and rain, and are related with leadership and territoriality. For this reason, for Aboriginal people, this meteorite and the manipulation of this meteorite have a very important political relevance. Are understood as stars fall to the earth, and for this reason, the Creole excavations or to extract these pieces from the earth are considered as metaphors of the Occidental domination. And also the meteorites are now symbols of the struggles of these Aboriginal people for lands and cultural rights. And for example, the first film about Mokoit people from 2011, the Hidden Nation in the Meteorite, it's a film about this Aboriginal people identity and is connected with the meteorite. The meteorites are also touristic attractions and cultural attractions, and we have a very large meteorite park in the region, but also attract a lot of people that are interested in take fragments from this meteorite and sell in the black market. This is a very, very big issue in Argentina today, and we have a lot of problems with this. In fact, this man, Robert Hag, tried to steal this very big meteorite, El Chaco meteorite, in 1990, this 37 tons meteorite. They tried to steal this, and for very little they don't succeed in this action, and many people sell these meteorites in the black market. Please don't buy any meteorite from Campo del Cielo. But also scientists and artists have problems to have a good behavior about these meteorites and their cultural relevance. For example, these are two artists from Buenos Aires in Argentina that started an artistic project about Campo del Cielo, but in 2011, they intend to move El Chaco meteorite, this very big meteorite, to an art exhibition in Germany. And, you know, it's a very important meteorite in Campo del Cielo for the local population, but they don't talk with anybody, any local community. They don't talk with experts or the National Organization of Protection of this kind of issues. They talk only with the governor of the province of Chaco, and they try to arrange the moving of the meteorite without any kind of consultation with the people. Obviously, they have a strong opposition for the local people, because the danger of this moving of this very large meteorite, but also because the lack of any kind of consultation with the local population and experts. And this is not an exceptional situation. This is maybe a very common situation. Experts and Aboriginal people opposed to this moving of the meteorite, and for this reason, the document artistic space desist to moving the meteorite. But the communication of the decision was very confused, and in English, not in Spanish or Aboriginal languages, and the people are very concerned for a long time about this possibility of the moving of this meteorite. The artists make some exhibition in this space in Germany, including a video and an iron cube, and they ridiculate the opinion of the Aboriginal population, and accuses them of fake Indians. And also they ridiculous the opinion of the expert that opposed it to this artistic exhibition. It's very important to take into account the importance of the free, prior, and informed consent for any kind of operations with meteorites, for example, that involves Aboriginal population. And this is not a gift, it's an obligation. And some of the important characteristic is these consultations need to be prior to the decisions, and using representative institutions of the indigenous communities, and the indigenous people need to be in control of the election of their representatives, and they need to be free of pressures and manipulation. Now we have in Campo del Cielo a process of patrimonialization that have some lights and darkness. Heritage is some kind of new language to a lot of complex processes, and have a strong links with the specific juridical languages and specific conceptions of property. The idea of culture as a value to protect, but with some specific points that, like authenticity, definition, conservation, that are all Western values about property. And you need these values, these specific Western values connected with heritage, are not politically neutral. For this reason, the claims about heritage are, in many cases, claims about ownership and rights, and for Aboriginal communities are connected with struggles about the definition of things, the definition of person and humankind, the conception of territory, the conceptions about ownership, the conception of history, change, and identity. For example, for the Western perspective, the importance of the meteorite connected with the impact, the cataclysm, the debris, the fall, the immobility of these very long iron masses. But for many of the Aboriginal people, these meteorites are connected with the underground, the territory, the time of origins, the powerful beings. They are actively sick humans, and also with the dreams. Are connected with shamanic experiences, with emotion, and also with coloniality. For this reason, the mosaification of meteorites is a complex process that needs to be in dialogue with the local populations. We are now involved in a very interesting project of training of young Mocoit guides for the National Park of Campo del Cielo for the meteorites, training young people to learn from the elders, but also from Western experts to be in the future guides of this space. And like final remarks, the Campo del Cielo meteorites are important not only because they tell things about the origin of the solar system, but also because they are part of a cultural landscape that include the forest and the past and present relations about human groups and meteorite and the relation among these human groups. Heritage is a possibility and a new language to talk about a lot of complex and very complex relations, and the international recognition of this kind of heritage have potentials for Aboriginal groups, but also some problems. For example, connected with the Western origin of the implicit notions that are connected with heritage. But we need to take into account that Aboriginal people are not relics of the past without history or without agency. They need to be involved in any initiative related to Campo del Cielo and other meteoritic dispersions, and the free, prior, and informed consent needs to be present from the very start of any kind of process. We need to remember that in many occasions, Aboriginal people are underrepresented in national governments and agencies, And we have this colonial logic very deep inscribed in our bodies and practices and minds, and we need to have a very strong epistemological vigilance to avoid the risk of reproducing these colonial patterns. Cultural astronomy, as think about astronomy as a cultural product, a social and cultural product, have a key role in the articulation of the academic astronomy community with the local populations. We need to be involved with people if we work, if we try to make a work that have impact in people. And also science, culture, art may point the way for governmental logics and not vice versa. Thank you very much. You are mute.
Rosa, can you let me say something?
Sorry, Alejandro. Thank you very much. It was a very special contribution, and I think that we'll learn many things from.
Can I say, Rosa? Can I
presentation.
say something? Can you hear me? I would like to point out something about the Alejandro presentation, because we all the time are speaking about inclusion, but we need to change our attitude about this kind of topics, because inclusion involves the rest of the people, not is our own feeling. And I would like to give my thanks to Alejandro, because he is doing a very good job, very hard work here in Argentina and in other countries. And I hope also the International Astronomical Union working group can make something, because we need to change the mind. It's not just don't buy the meteorites which arrive from different parts of the world. To me, it's very hard to see the Campo del Cielo meteorites in the museums, for example. I don't know how these meteorites arrive to the museums all over the world. Honestly, I think it's not an exchange between the governments, and less an exchange with the local people. So this is an important topic. It's a topic connected with humanity and with the recognition of the others. And we need to do something, because if not, the word inclusion, diversity, equity has not any sense. These words has not sense if we don't make the right things. So this kind of presentation is very important for us to show that we have some power to do something, and we need to do something. So thank you very much, Alejandro, to accept present this topic here. Thank you very much.
Thank you.
Yes, I think it was very interesting for us, because change some previous ideas that we have, and it was very interesting to broken some of them. Thank you. In any case, the next roundtable include some histories from different countries about it. There are many of them, because I can see that Hugo from Mexico say that has also similar history, and I am sure that there are many of them. But well, this is one possibility to begin to exchange information between us. Thank you. I would like to open now the next one session, the next one contribution for the next round table that we have. This is the last one. This is, I would like to show you my, okay, my screen. And the next one speaker will be from Colombia, Ángela Patricia Pérez, from Paraguay, José María Gómez, from República Dominicana, Carla Peña, and from Mexico, Valeria Buenrostro. Then the first speaker is Ángela. I saw Ángela.
Yes, I'm here. Thank you, I'm here.
Excellent. I see you. Okay. If
Thank
you want
you.
to share with us.
Yeah, I'm going to share my
Bienvenida.
screen. Gracias. Thank you very much for having me here. I'm Ángela from Colombia. I'm the contact from NASE here in Colombia, and I work in the planetarium of Medellin as well. So I'm gonna start my presentation. We have here many NASE's workshops in Bogotá, Medellín, Barranquilla, Tunja, Bucaramanga, Ibagué. We reach more than 300 teachers over the past 10 years. So it's very nice to have NASE here. We're gonna start again doing NASEs because they always have very interesting topics. So I'm gonna talk about my presentation called like Santa Rosa de Viterbo, Beder Tocativa. It's most of the famous meteorites here in Colombia. So I decided to talk about them because the story is something about Alejandro was talking about. This meteorite was found here in this is Colombia, and this is Santa Rosa de Viterbo in Boyacá. We have 32 departments here in Colombia. And here in 1810, the same year of the independence of our country, the people here found something very special, that is this meteorite. In that year, 20 years after that, some astronomer, this is not an astronomer, geophysics, study the rocks, these kind of rocks, and study very perfect decomposition of this material, and ask the people how they find this stone in Boyacá. They tell the story to him. He write it down and found another rocks like this that are meteorites. And that's why the planetarium of Medellin, the planetarium I'm working on, is called Jesus Emilio Ramirez Gonzalez, that this is the Jesuit father that work in that period of time, study the rocks. The rock has a very special story because in that year, 1810, Cecilia Corredor, it was like a Saturday after Friday holiday. Everybody see like a rain, falling fire rain. And the next day, Cecilia Corredor find a huge stone in their, like near to their house. She couldn't move it, so she went to look for another people to help moving the stone. They do everything to pick up this stone, this meteorite, because it was very cold, very special with the hose and stuff, and they move it to Santa Rosa. That's why some people said this is not a meteorite from Santa Rosa de Viterbo, but it must be Tocativa because it's the place where the stone was fallen from the skies. In that place, Museum of here in Bogota, find this rock and buy the rock from Cecilia Corredor. But it was impossible to move it from Boyacá to Bogota until Henry Ward, it was a hunter of meteorites, came from USA, talked to the mayor of the city and do something like an exchange. You can give me the rock and I give you a statue of the president of that period of time. It was Rafael Reyes. And they were talking about doing that. Finally, the mayor said, okay, we're gonna do it. They talk to the people doesn't agree with that idea. So they create a great party that night. The people went to the party and Ward and their team take the meteorite and take out of the city of Boyacá. The rock arrives to Bogota, and some journalists realize of this movement of the rock and said to the government, hey, look, the rock is going to be out of the country, so you have to do something. They stopped the thing, but Ward, this hunter meteorite said, no, I talked to the villagers and they said that I can't take this rock from the country. So, well, was a discussion there, but fortunately, they give them a part of this meteorite. It's like, at the beginning, this meteorite was like 600 kilograms. They given to him to Ward like 120 kilograms that he divided in many different places all over the world. So you can find meteorites from Santa Rosa de Viterbo since New York to Japan, and also like 400 kilograms of small pieces of this meteorite when they cut it down. And this is a group that I went with the little ones to the museum in Bogota to study the meteorite, to see the meteorite, and to study the story. But it's not the only place that we found meteorites here in Colombia. We find as well in Cali. Some people there see the falling rock in the sky of Cali. It was Asafi and the Astronomy School of Cali that they were gathered with many people to go and look for the meteorites. They asked the people if they hear, because they hear the sound of the meteorite falling, and they try to find the meteorite. They find it, and if you want to visit Colombia once, please come here to Bogota in the museum, and also in the Museum of Cali. And you're gonna find this little piece of rock from the sky. In that sense, we do many activities here. One of the activities is that we look for asteroids since like 2017 with Enrique here in the Planetarium of Medellin, and we are encourage students and teachers to find their own asteroids. And of course, we're gonna join to NASE's, to Beatriz and Rosa, looking for meteorites, because it's very exciting to look for that kind of small pieces of the space here on Earth. And in this part of Earth in Colombia, we are gonna do as well the Festival of Asteroid. We changed the date because we want to remember the 20th of April of 1810. That was the first time we found a meteorite here in Colombia, and it has a very interesting story to count. So thank you, everyone. And if you want to contact me, please let me know. I'm very excited to work with everybody of you.
Thank you, Angela. Always your contributions are very good. Thank you. And the next one speaker will be, sorry, I have here the list. I think is from Paraguay. Yes, Jose Maria Gomez. Also, Jose Maria arrived here before I saw.
Hello, everybody. Can you
I
hear
don't
me?
know what it is. Ah, Jose Maria.
Hello, hello.
Could you share with us your PowerPoint?
Of course, right now. Well,
yes.
Can you see my screen?
Yeah.
Well, thank you very much for the invitation for participating in this interesting event. Well, I'm Jose Gomez from Astronomical Observatory Alexis Troche of the Polytechnic Institute of National University of Asunción. I will talk about meteorites and some curiosities about experience here in my country, Paraguay. One of the experience is related to the news about meteor showers that always the main newspaper web page is talking about, like Leonids, Taurus, and Orionids in November, and Aquarius in July. And other event is related to fireballs that from time to time we see here in our sky. We have a planetarium where we can see meteorites that we can visit it in Asunción. And then that is some experience that we can have here. Well, in our observatory, most of the people can and always are asking about what is a shooting star. And then most of them think that they are a really star. Then I need to clarify them that is not a star. And after that, trying to explain what is a star is something like our sun, the structure of the sun. And to other thing is to make different what a shooting star with a meteorite and how it is related to meteor showers. And that is a common subject for the people and students that came to the observatory. I had personally experience to be in a great science museum in La Plata in 2016, and I saw a great meteorite. And this year I've been in Buenos Aires, and I had a wonderful experience to see that kind of object. And some point to remark is that meteorite is an interesting subject for most of the amateur astronomers and the public in general in Paraguay. The press is always informating about some event related to meteorites, fireballs, meteor, etc. The NASE 2023 proposal on micrometeorites will be an outstanding complement for the public and students, because it's not just for talking about meteorites, it's about to do something about it. Thank you.
Thank you very much, Jose Maria, for your contribution and to control so good the time, because it is interesting to have time for discussion. And the next one speaker is from República Dominicana, Carla Peña.
Yeah, Carlos Peña.
Carlos.
Yeah.
Perdón.
Hello, everyone. Let me share my screen. Hope you can hear me well. My throat is a bit sick now.
No, it's fine. Don't worry.
Perfect.
We understand you very well.
Let me check. Okay. Can you see my screen now?
Yeah.
Perfect. Well, I'm going to talk a little bit of the landscape of meteorites and astronomy in the Dominican Republic, because right now we're really behind into meteorites, but we have a lot of opportunities here, and we're beginning to take advantage of them. I'm Carlos Peña. I'm part of the Dominican Astronomical Society, and I teach nautical astronomy at the local nautical academy. And the Dominican Republic, we have a particular situation, because we have a particular orography. We're very mountainous. The island is full of mountains and right in the tropics. So we have a lot of vegetation, thick forest, thick jungle. So it's very difficult to find meteorites here, except in some areas. If you see a map of the climate of the island, this is just the Dominican Republic is 2/3 of an island. We share the island with Haiti. And on our side, we have mostly humid and very humid climate, except for two places. And those two places are exactly the places where meteorites have been found here. I guess because of the east to find the meteorites there. One is about here. This is a small 15 kilometers in length sand dune desert, and the other one is right here in the southwest corner of the island, where we have a very dry desert-like climate with sparse vegetation. But this is what most of the island looks like. It's very thick, a lot of green, and it's a very mountainous place to find meteorites in. It's very beautiful, but for meteorites, it's not ideal. It's way too difficult. And even if we have a recent impact, it's erased very quickly. So there's no easy way to find it. But in Bani, in the first place I mentioned, we have this. It's a sand dune desert. It's a peninsula with sand dunes, and the sand dunes shifts with time. So heavy objects accumulate in some places. So there are good places to find meteorites. The problem is that we have to discriminate between heavy non-meteorites and meteorites, like hematites and magnetites and meteorites. The other place is around here. This was a few dozen million years ago a huge cave system that collapsed. Some hypotheses are that it collapsed because of a meteor impact nearby. But in this place, they usually find heavy rocks containing a lot of iron and nickel. And now I'm going to show you a sample of an iron nickel meteorite found around this place. But in this place, we have another problem. We've begun to install a lot of mines, and the geologists at the mines, they are not looking for meteorites. They're looking for nickel, for gold, for silver. So they're not really interested in the meteorites. But we started talks with them so we can share information and help them discriminate and just get the meteorites they find that they are not interested in and put it in a museum so that people can see them and enjoy them. One of the advantages we have is really dark skies. So we've recently been seeing a huge increase in amateur astronomy, and everyone here is getting into it. So we've seen a huge increase in meteor sightings, and now we have a lot of astrophotographers. So we have a lot of pictures, and it's ironic that the only paper published by Dominican people about meteorites is not because of a meteorite on the Dominican Republic, but on the moon. We had a paper published on a meteorite impact on the moon on 2019 during a total lunar eclipse. It was a boom, and that made a lot of students, high school students that were finishing high school, get interested in astronomy, in studying astronomy. We don't have astronomy careers here. We don't have that class in the universities here. So what they do is they get into physics, and then they switch over to astronomy. When they're doing the postgrad, they go to some other country to have a degree in astronomy. So we have a lot of nice pictures of meteors, but not many meteorites. This is one of the sightings that we guess that it hasn't been found yet, but we guess it impacted Earth. Is that light in the middle, that one here, because it was seen from a lot of places in the country, but it was not on the dry part of the island. It was on a densely populated but thick, a green lush area. So it would be very difficult to find the exact location of the impact. So we've seen a lot of this. This was in 2019, 2020. This is 2019 too, and 2015. So in the last 5 to 10 years, we've seen a huge increase in sightings of meteors, but not much meteorites. So we approached the universities here and the Institute of Geology And they have a huge problem with classifying rocks because they don't have enough people. They have a huge backlog of tons and tons of rocks unclassified. They know they must have some chondrites and tektites there, but they haven't classified them. So we're starting to approach them and find out how we can help get some astronomer classifying them. So they have old classrooms just storing rocks and rocks everywhere without classification, without discrimination, and a lot are lost. But some people have identified meteorites and kept them for themselves. This sample is the only sample I could find of an iron nickel meteorite and in the Dominican Republic, but it's in the hands of an engineer. It's a private hand, so it's his sample. It's not open to the public, so it's not shown. It's a small sample of a few small rocks. This is about 10 millimeters wide, and it was found on the mines in the southwest of the country. So we're in a dire situation here because we need to find all those meteorites and show them to the public. But we have the opportunity now. So in conclusion, we have the problems, the challenges of the climate and plant cover, the orography. We don't have specialized research in meteorites, not even in astronomy. All of our astronomers are out of the country working for some other country. We have a huge brain fugue. So we're losing the scientists to other countries because they leave for other countries to do research. So we have to promote the interest of the public so other countries help the Dominican Republic investigate and research on this topic. And the other problem is the mishandling of samples because the mines usually throw away the samples that they're not interested in. And that includes meteorites. They're just interested in what they're mining, so what makes money for them. But we have the opportunities of the huge increase in public interest into sciences. We have widening amateur communities. And in the latest years, we've seen public outreach events with thousands of people looking through telescopes and talking about astronomy. We have very dark skies. That's one of the advantages of an island. We have stable climate, and the population is concentrated in 2 spots in the island, two big cities, but the rest of the island is very dark. So it's very rural. So we still have dark skies. Even with the tourism is concentrated where the big hotels are. So everywhere else is very dark. We have a stable political and economical landscape, and we've seen a huge increase in students interested in astronomy and other STEM careers. For example, the physics bachelor's degree in the state-sponsored university here went from 2 students a year getting into physics to 20 students a year in 2 years. Just because of all of the outreach programs we've been pushing forward here to try to get them to get students interested. Not only interested, they are already interested. It's just that they thought it was not feasible to study sciences here. So we had to show them, hey, it's not only medicine or law or bookkeeping. You can also go to sciences if that's what you like. And most students just lose that interest in sciences because they think it's not possible for them to go that route. Some of them even go further into astrophysics. We have a couple of astrophysicists, Dominican astrophysicists in other countries, working for other countries, that would love to get them to help a little bit here with the classification of these samples of meteorites before they're lost. Because I know the university, the Geology Institute will get rid of a lot of samples soon if they don't classify them and put them into this place soon, because they don't have space. They're running out of space and they have a lot of rocks just laying around and being wasted. So that is all for the moment. Thank you very much.
Thank you, Carlos. Thank you very much for your presentation, your interesting presentation. And the last speaker is Valeria Buenrostro from Mexico.
Hi,
Hello,
Rosa.
Valeria. Welcome.
Thank you. Let me share my screen. You can see it, right? Yeah, okay. So sorry, I will leave it like this because it's easier for me to control it. So I am going to talk about the most famous meteorites in Mexico, the Chicxulub crater and the Bacubarito meteorite. So initially, I wanted to focus only on the Chicxulub crater. This is probably the most famous impact on the planet Earth. It happened.
Valeria, do you, in this moment, we cannot see the full screen.
You can't see it?
No, not yet. The full screen.
What do you see?
Yes, we can see the list of the 5 small slides, but not the full one.
Okay.
You are not in presentation mode.
Yeah, the thing is that if I go to presentation mode, it messes my layout a little bit.
Let's try. If you cannot go back.
No,
it's okay. It's okay.
Yeah.
It's fine.
It's okay. Let's go.
Okay. So as I was saying, this impact is probably the most famous one. It happened 66 million years ago. It happened in the peninsula of Yucatan by an object that was estimated to be around 10 kilometers wide. And it left a crater of 180 kilometers in diameter and 20 kilometers depth. It's a very, very big crater. And around this time, we know that 75% of life on Earth suddenly died. And mostly dinosaurs, most of the dinosaurs were the ones affected. So we believe that this was the cause, that there was a big object that impacted on Earth and it destroyed most of the life on Earth. But I don't want to focus on this object, even though it's the most famous one, for 2 reasons. The first one is that we don't have the rock that caused this. And the second reason is that this rock was so big, it was 10 kilometers, that it was probably an asteroid, not a meteorite. And the talks today are about meteorites. So meteorites are fragments of asteroids. So because of this, I will talk to you about the biggest meteorite that we found in Mexico. It's called the Bacubarito meteorite. And it was found by a peasant who was probably very annoyed because he kept trying to plow the land and he kept banging against a very hard and big stone in his land. And then this became part of the Meteorite Institute of Mexico. It was discovered in the year 1863, more or less. So it stayed underground for many, many years. It was just a small piece of it that was above the ground. And later on, this same meteorite hunter that Angela talked to us about in Colombia, Henry Ward, came to Mexico to have a look at this meteorite. And he had 30 local peasants extracted from the ground. So this photo that you see are these peasants that removed all the earth around it so we could actually see it. We could then notice that the meteorite is very, very long. It's the longest meteorite that we have on Earth. It's not the biggest, but it's the longest. It has 4.2 meters long and 2 meters wide and 1.7 meters height. So compared to the biggest meteorite, which is found in Namibia, this one was 2.7 meters long. And compared to the Bacubarito, which is 4.2, it's almost half the size of Bacubarito, but it's much larger. The largest meteorite weighs around 60 tons, while Bacubarito is only 20 tons. So it's very long, but it's not very thick. And it has a very strange shape. People say that it's shaped like an ear. It is composed mostly of iron. It has about 89% of iron. Then it has 6.98 nickel, 0.21 cobalt, and then it has other elements. And this combination is very strange. So this is a very unique meteorite also because of the composition. There hasn't been any other meteorite found with this composition. And we don't know when it struck the ground, but some scientists believe it was around 2,000 years ago. So after these geologists extracted it from the ground, it stayed there. And the government built a house to protect it, made of stone. But in the year 1959, it was finally transported to the city of Culiacan. And this was done behind doors. So the people that lived in this place, it's called El Ranchito, where the Bacuberito meteorite was found. They were not very happy about this. So it was transported into a very big park, and it stayed there for some years until in 1992, it was finally moved to the Science Center of Sinaloa, Culiacan. Culiacan is the capital city of Sinaloa. Unfortunately, it is known for the narcos, but it should also be known for the fact that it has the 6th largest meteorite in the world and the largest meteorite in Mexico. So here are some photos, and the one on the left is when it was in the park, and the one on the right is when it was finally in the Science Center. And it was out there for around 20 years. And of course, since it's made mostly of iron, it started to oxidize, and it started to degrade and lose mass. And it also has some fissures in it, some cracks, and we believe this happened when it entered the atmosphere, that it started to crack. And these cracks are becoming bigger because of the oxidization with the atmosphere. So the center decided to take it inside. So in 2021, they moved it inside into a special room where it takes care of the humidity and the temperature, and people can still go and visit it. And that is all from me. Thank you very much. We can't hear you, Rosa. You're muted.
Thank you very much for your presentation, and also to control so good the time, because I have time for discussion. Not a lot, but some minutes that I think it's interesting if you want that to have the opportunity to exchange comment between you, between the meteorites and all the things that we consider in this session. I don't know if maybe you have any questions to Alejandro. I think it was the more complete presentation because, of course, he had more time.
Rosa, can I ask something?
Yeah.
I didn't really understand the way that we collect the dust is after rain, or we can do it.
Doesn't matter. Doesn't matter. Well, there are two methods. Ricardo only explained the method used in places that we have, how do you say, more salmon and more dark cities. But if you are living in another area, also you can collect with a tramp, and you put one piece of ceramic or one piece of something that you use in your kitchen. You put over there a film or a cellophane paper, and you wait for several days, and after you collect the dust that you can find there. And after you choose with a magnet, the part that it is iron or nickel or something like this composition. There are the two options. And for our cities, the method of Ricardo is very normal and very simple. But in other cases, I think In Bulgaria, for instance, Ivo show us the other method with one object, no, where big object that put over there a cellophane paper and after collect the dash. Then there are the two possibilities. It depends on your city and the place where the students are living. Then is your decision. I think that, for instance, in my case, I did it, and I did it the method of Ricardo. Really.
So we have to collect for about 15 days, for instance.
No. Can I suggest something?
Yeah.
One week is enough.
Method you use
just a comment. 1 week is enough. You put the cellophane paper on the plate or a big dish, and you wait. Try to separate the dish from the ground to avoid the dust around it. I made experience at home in my own backyard, and I separate from the ground a little. Put the dish on some table or somewhere, and with a free sky. Don't try to avoid the trees and the walls and so on. And 1 week is enough. You will have a small quantity of dust. Most of the dust is from the ground, but the micrometeorites are mixed, are there. Not in a big quantity, but enough to separate from the dust from the ground. So it's not a long experience. You don't need that the rain arrive. With these reservoirs of dust in the floor is good, because in the ceiling you have a big collector, you have a big trump, but it's the same with a small one, and with a week waiting, don't touch anything, waiting for the nature, just the nature. So it's not a very long experience, it's a short time, and the collection is quite good.
And the reason for the second method, I mean, we go and search around places where water is can be drained. Which is why to search there?
Because the rain is moving all the collection of the dust on the ceiling, so you have the opportunity to put all together with the water, the drain. You produce the collection in a small place of the micrometeorites and all the dust. The rain is good, of course, but if you have not the chance to go on top of your house, you can use the dish, a big dish, and it's enough. You don't need to wait for the rain. You don't need to wait for a long period of time. And if it rains all days, you have no time to collect micrometeorites. So you need to decide what is better for your own habitat. Okay.
My final question. Can we make a chemical composition reaction to be sure about the meteorite composition?
Well, it's a bit difficult. I can suggest, if you have a good magnifier, to try to classify in different kind of objects, or spherical, but with different small differences in color, for example. But to make the reaction, the chemical reaction, I'm not sure. We didn't do that. This experience is a bit complicated because the amount of matter you have. So probably it would be difficult. I'm not sure because I have not experience. But the difference between the small differences in shape and in color with the good magnifier is possible.
I would like to mention that Ricardo Moreno is not here, but I think it was Ricardo that found one sphere with a small bubble in one part of the sphere. No, it was like a rest of the solidification very quick. No, but Ricardo is not here. But I think it was one micrometeorite that he found. Really, it is a very, very simple way to do it. And I did it in my terrace, and it is not difficult. It is only, if you go to the area that the water go there, then the water collect for you all the possible candidates to micrometeorites. Then you have all them more closer together. No?
We have 3 raises hand. Tomita, would you like to say something?
Okay. Okay. Thank you very much. Thank you very much. So so first of all, finding the micro meteorite is very interesting. Now I think it is one of the familiar experiments in a local science center in Japan. Actually, I didn't do that, but I know that it is a very familiar experiment. And my question is that, can we expect some variation along the season? For example, in January and February, we can expect more micro meteorites, and in summer, we don't. So this is because of lack of my knowledge, but if you know something about the variation along the year, so we can do the research topic about how is the variation from summer to fall. So in what season can we expect more micro meteorites? So this is my question.
Well, I have not the answer, but
Okay.
I don't know if someone here can answer that question, but it's a good proposal to,
Yes.
for example, make the activity at the same month for
Mhm.
everyone during a week, the same month, and repeat the experience along the year. 1 week is not a problem. You don't need to make anything. You put the dish at the backyard and wait for a week. Would be good. It's a bit difficult to count the number of micrometeorites you have in the set, in the
Yes,
group.
yes.
It's not so easy because you make an scanning with your cell phone, your camera,
Mhm.
over all the material, but it's not so easy to count one by one. Perhaps if you use a microscope or something graduate, it will be better to count for regions as we count stars, for example.
Yes, yes.
So the activity needs to be well performed to make more measurements. That is just an inspection, not a count of the micrometeorites in the well set that you have.
Yes.
Alejandro and Corina has the hands raised. Alejandro, if you want.
It's only a comment about the idea of to take some kind of analysis of the composition of the meteorites. You are using a magnetic method. This allows you to say that you have iron in these fragments, and the more detailed classification of iron meteorites depends on the crystal structure, not especially in the composition, but especially in the crystal structure. And you can't see that by any kind of chemical reaction only. You need to coat meteorites and to take some method to analyze the crystal structure.
Yes, I am thinking right now about how to do that. And the micrometeorites are very, very small, but it has the shape of the point of the pencil. So, or the size of the point of the pencil are small, but not smaller than, it's impossible to put a drop of something to analyze the reaction, the chemical reaction. So we can try to do that. Thank you, Alejandro. And Corina?
My question is about the powerful of the magnet, because you told us that we can find nickel, and nickel is diamagnetic, and because of this, the magnet has to be neodymium, I think.
Well, in this sense, I can say that I use different magnets.
Okay.
And the magnets work more or less well to discriminate micrometeorites, not to determine the composition, the real composition, the chemical. But I use the common magnet for the schools, are not neodymium magnets.
Yes,
are enough.
iron.
Yes, are enough.
Yes,
I try with the dish and the cellophane paper and a common, very common magnet, and it works. So the neodymium are better because are more powerful, but almost any kind of magnet is good for the experience, to separate. I
asked you because we want to buy for the Centrum, I told you.
Yeah, the neodymium magnets are expensive, but the magnets for schools are cheap. So
yes, thank you.
Remember, always remember to make the experience before to go to school and to work with the students or the teachers, because if you test for the first time in the middle of the class, probably you will lost your mind because nothing is good. So not surprises at the class. Remember that you need to test. A week is a very short period of time to test, is enough, and you will see the cellophane paper, how it's collecting the dust, and each day is a little more dirty. And at the end of the week, you have a lot of dust there and some micrometeorites. But test first at home. Because of this, I can say that different magnets function in any case. So,
well, I would like to say that there are many schools that they have neodymium magnets. For instance, in my country, and we use it. One of them. It's very easy. I suggest according with Beatriz that you test, because it looks more difficult than really what you are doing is very simple.
Yes, remember that these kind of experiments are good to check what the school, the laboratory of the school has, because normally the schools don't know what is in the laboratory because not all the teachers are using the laboratories frequently. So check what is in the school, and if in the school there is nothing, a common magnet could work. So would be good.
Also, in support of your idea, Beatriz, is the presence of nickel in most meteorites is very slow. You have a more lot of iron in the meteorites that have also nickel. For this, is not problem to use normal magnet, I think.
Give me a moment, I will go to show you something.
Beatriz, Rosa, can also Beatriz send us a picture, a photo of her selector?
I'm here again. I use this, even this thing is a fridge magnet.
Yeah.
And this, you see, it's a memory, a souvenir. And this also works very well, because a test, if you have magnets as souvenirs from some parts of the world, some of these are very powerful. Others are, but look at this, is a good magnet, not a film, it's a magnet. And this works very good And even if you look at the magnet with you separate the micrometeorites, with a cell phone, you can see here as a field, campo del cielo, a field of micrometeorites here, a lot of spheres on the magnet. So you can see here the micrometeorites. So test what you have at your house, and probably you don't need to buy anything. You can use what you have at home.
Well, but if you need to buy, I buy this one, concretely in one place in Spain that we buy all the things that you need to solve the problems in the house, like something for kitchen, something to make a hole in the wall, all of this. And this kind of shops is very easy. And this was a couple of euros. Then it is not expensive to find one of them. It's very easy. And I suggest that you try to find one at home, or in other case, you buy one, no problem. It is simple. It is funny. And always is like surprising, no? Because you go on, really, I can do it. This is good. Okay, then I suggest that all of you try to do tomorrow, next week, and after you send to us your photos, because we want to prepare a collection of photos of your micrometeorites. And well, if you find something special that you explain to us or show to us.
I have one more raised hand. Wait a minute. I don't know who is.
It's me.
Margarita. Yes, go.
Please send me a photo of your selector.
Okay.
Angela?
Beatriz, it's possible to for you to show this experience in NASE network page? It's already writing?
I believe Rosa is uploading the detail.
We are finishing, and we are, in this moment is the explanation in English. I don't know why it's impossible to put in the Spanish area in Spanish. I don't know why. I have
if
to
you
ask
if you need any help, I can make it.
It's the same information that you receive, because I made to all of you. Okay.
Yes, we
you
sent
have a leaflet with 3-4 pages, and after one table where you have to put the name of the country and all of this. Okay. Now it's in the website now, but it's not yet. It's in English in all the places, in all the countries, but in Spanish it's also in English, because I don't know, but we have problems to put the other file. I don't know why.
Yes, but remember the people in Latin America received the files in Spanish, I think. If you have not it, please tell me. But we distributed the material in NASE America. So please let me know if you didn't receive it, because all is more or less well written. It means the description, the procedure, and what you need to send to NASE to demonstrate that you perform the activity. Remember that the bridges between cultures is the starting point for this activity, and we have a closure, an ending for the activity will be in October, and we have the full year, or this month between now and October to perform the activity. And if you have any question or doubt, we are here trying to answer your questions.
Well, the process is for equinox to equinox. Tomorrow begins and finish on September 23, but we are planning on even online event or face-to-face or both. It happens.
Yes, hybrid.
In October, but it's not yet decided because we have to solve some problems. But we give you information. In any case, please try to find meteorites. Jose Angel Mora?
Yes, thanks, Beatriz. Good day, everybody. It's really fun. It's really fun to look for micrometeorites in the rain ducts, in the rain channels. But I have found several. But my question is not how to collect, not how to picture it, is how to preserve them. How do you develop it? A procedure to keep it in physics, not the photo, used to keep the micrometeorite. I was trying to stick them with crazy glue, with the cyanoacrylate glue in the very tip of a toothpick. So I have several toothpicks, each one with a micrometeorite in the point. This was I think it will work to keep them, and then place the toothpick in an image still form to keep them vertical. To have a small collection of micrometeorites.
Yes, good, very good idea. You can use a tape, a glue tape, exactly, and well, in a tape you can conserve the micrometeorites if you collect them in the magnet, or if you collect them in your finger because the micrometeorites are are glue in the fingers. You can put the tape here, and you can preserve the micrometeorites. Yes, it's good idea. I support very much this. Alejandro?
Yeah, it's only a comment about in this process, in this experience, try to take into account the cultural and local aspects of all the things. Because you see in many of our presentations, the people talk about some meteorite, a large one, but it's moving to another place and the local people is not very happy, and it's all we talk about the local situation. Only the people is not very happy and go on to another thing. I think these relations of the people with meteorites, with animals, with the forest are very crucial to teach science that makes important for the people, because if we teach science as a separate issue with not connections with people's lives, we don't have succeed in any way. We need to make these bridges with the people's lives and emotions and histories and values. And we need to take this into account in all the experience that we design.
Yeah, I agree, fully agree, Alejandro. Thank you for saying that.
Excuse me, and also it's an opportunity to discuss about controversies of different kind of conflicts among institutions and local populations. It's interesting to merge science experiences with social science classes.
Yeah. Exactly. Valeria, you want to say something?
No, I was just agreeing with Alejandro that it is important.
Yeah. I would like to ask you, Valeria, because you mentioned that the meteorite was moving from the original place to the museum and again to the new museum. If the local people is asking for the meteorite, come back home meteorite or something like that, or just the discussion is finished?
I ignore that. They moved it in 1959, so this was some time ago. And there isn't much information about this meteorite, I must say. So I really don't know if they are still angry about this. I know that they were angry when this happened because it was done behind closed doors. They didn't ask for permission or anything. So after it was maybe 70 years that it was in El Ranchito. They just moved it. So, yeah.
Yeah. Okay. Well, if you help us to take the group photo, I suggest to turn on the cameras for the people who is not with the camera on, and I will try to take screenshots.
Yes.
We have two screens, so no, not a lot of people. So, well, I will open. Well, no, that doesn't matter. And well, 5 seconds. 5, 4, 3, 2, 1. Here is the first one. Save. And the second one. Give me a moment. And ready. So, Rosa, if you want to close
yes, I would
the
like to mention after to finish that we are planning to publish a book with the contributions of all the people that present a PowerPoint, of course, and a presentation about the topics in the different roundtable and also the speakers. Then I will email to all of them some information about this, and I hope that they can participate, all of them, because well, in general, the contributions are very, very good, and I think it could be interesting that all of us have a reference of these contributions if we want to revise during this half a year that the project finish in half a year, or after that. Then I think it is a good opportunity to do it. This is a photo of, I think, of YouTube.
Yes, it's Jose Angel sharing a photo of the micro meteorite with a pencil.
Yeah. Well, this photo is made by Ricardo. He used one simple thing to obtain a better images. It was to put a little bit of part of the how do you say, the gel that we used during the COVID process in the ocular of our cellular in order to obtain a better definition. It is a simple way to do it, but if you can use another device, that it would be better, maybe a microscope. But if you don't have it, then this is also a good solution. Well, thank you very much. And I give the information to all of you for the book that we prepare about the third Bridges of Cultures. It was a pleasure for us to expend these 3 hours together. I think it was very interesting that all the people participate explaining their feeling and their situation in their countries. We can learn, all of us, from the other ones. And thank you very much. I don't know if Beatriz.
No, just to give the thanks to the people in the chat in YouTube. Remember that this meeting will be on YouTube forever, I hope, and you can suggest to revise our YouTube channel to remember the day of today. So just to give my thanks, my personal thanks, Angela. No, it's not a raised hand. Thank you very much for everybody and to be here very early and very late on the planet. Thank you very much.
Thank you to all the participants from Asia that they are sleeping now, from Europe, Africa, and America. Thank you to all of you.
Thank you.
We are a very big family, and it's a real pleasure to enjoy this kind of meeting.
Thank you.
Thank you.
Gracias, chao, gracias.
Adiós, adiós, chao, Ángela.
Bye,
Adiós,
bye. Chao,
Elena.
Beatriz, abrazos. Chao,
Adiós, abrazos. Ligia, Ligia, Juan Carlos.
I didn't see you.
All the people from
Thank you.
America.
Bye.
Bye.
Bye bye.
Yeah. And to Ruti.
Bye bye, Rosa.
It is very nice.
Bye bye.
Okay. Ellie from Mauritania. Hello. Thank you. Bye.
Bye, Rosa. Bye, Beatriz. Big
Ciao,
hugs.
ciao.
Big hugs, Beatriz. Thanks a lot. Thanks a lot to
No,
make it
gracias
happen.
a ustedes. Hugo, Durruti, many people from America too. Bye bye.
Yes.
Bye.
Saludos.
Adiós, Rosa.
Adiós, José from
Adiós.
Portugal.
Me gustan haberlos visto.
Bye bye.
Adiós.
Un placer.